About it briefly yesterday. You don't need to write any of this down. I'm just going to refer to some of it, okay? But your learning target for the day is to graph exponential functions, okay? Graphing exponential functions. I had you write that down, that learning target down yesterday. So that is what our goal is today, okay? First of all, exponential functions are different than what we've done so far this year. Quick recap. Start of the year, y equals x. Linear functions, lines, right? Y equals mx plus b. M is your slope, b is your y-intercept, and so on. Okay, that was a quick Algebra 1 review. Gotten really into the quadratics for a while. Okay, y equals ax squared plus bx plus c. Quadratic formula, factoring, square roots, complex numbers, imaginary numbers. Okay, we got into that for quite a while. But x squared, y equals x squared, quadratic stuff. We did some absolute value stuff for a while, okay? The V-shaped graphs, shifting left, right, up, and down, okay? Did some piecewise functions, did some radical functions last chapter, okay? Square roots, cube roots, and so on, okay? All of these, x was really your base, okay? X was really just a normal base of a number, all right? You had different exponents. You had x squared, x cubed, x to the fourth, x to the half, x to the third, x to the fourth, things like that, okay? But never before has the x been in your exponent. Never before has the variable been in your exponent, okay? And that is what we're going to be working with a lot, is exponential functions, okay, this chapter. All right, I talked a little bit exponential functions all over bank accounts, compound interest, amount of ibuprofen that's left in your body 30 minutes after you take it, an hour after you take it, and that sort of thing, okay? How fast your body metabolizes it, okay? Carbon-14 dating and dating fossils, how old they are, okay? Other applications that we'll use, okay, this chapter all kind of go to this exponential functions, exponential growth or exponential decay. If you had me in Algebra 1, we talked about it briefly, okay? We did a little bit with exponential growth and decay, not as much as we're going to do this year, but it should at least look familiar to you guys, okay? So that's what we're going to see. You're going to see where the variable now is up in the power, okay? Alright, so here we go. Learning target 7.1. We're going to work a lot with exponential functions. Okay? And exponential functions usually take the form y equals a times b raised to the x power. Y equals a times b raised to the x power. Where a and b are usually, not usually, they are some real number. Okay? You might not see an a value there all the time. If you don't see an a value, just assume it's 1. Okay, it might be y equals 1 times 3 raised to the x power, or 1 times 1/4 raised to the x power, or something like that. Okay, so you might not always see an a value, but there is always an a value there. And we'll talk about what the a and the b mean here in just a second. Okay? With that, I'd like you to look over at these table of values that I have. Okay? I wrote a couple exponential functions down here. Y equals 3 times 2 raised to the x power. Let's make a little table of values for that, okay? Let's plug some numbers in for x and see what we get for y here a little bit, okay? So let's start with 0. That should be an easy one. What's 2 to the 0th power equal? 0. Ah, come on. Anything raised to the 0th power? 1.
Are you sure about that?
Okay, yes. Anything raised to the 0th power is 1, remember? 2 to the 0th is 1 times 3 would be 3, right?
Should we write this stuff down?
Okay. This is kind of up to you. What you're going to do is you're going to see this and make a conclusion from it and write the big stuff down over here. But so that's up to you. Okay. You can kind of see as we go. You have time. Plug in a 1. 2 to the 1st power is 2 times 3 is 6. Plug in a 2. 12. Plug in a 3.
24.
Well, you got that fast. How'd you get that?
Because if you notice, they're just multiplying. You change it by 2.
Oh, you notice the pattern. Okay. Well, if you notice the pattern, what do you think it is when you got a negative 1 for your x value? 1.5. Let's see if you're right. 2 to the negative 1 power. Can you do negative exponents? No, you got to move them to the bottom where they become fractions. 2 to the negative 1 becomes 1 over 2 to the positive 1, which is simply 1/2, right? 2 to the negative 1 power is 1/2. So 2 to the negative 1 is 1/2. What's 1/2 times 3? 1.5, just like you guys figured it would be. Okay?
You wouldn't have got that.
Alright, okay on that one? We'll come back to it. I'm going to do a different one. Y equals 20 times 1/4 to the x power. Let's try 0. What's 1/4 to the 0th power? 1 times 20? 20. Plug in a 1. What's 1/4 to the first power? 1/4 times 20? 5. Okay? Second, what's 1/4 to the second power? 1/16. 1/4 times 1/4. 1 times 1, 4 times 4. 1 times 1 is 1, 4 times 4 is 16, 1/16. 20 times 1/16 would be 20/16, which reduces to 5/4. See the pattern yet here?
Yeah.
What do you think this one is?
80.
80. Let's prove it. 1/4 to the negative 1 power. 1/4 to the negative 1 power is 4. Times 20 is 80. Okay? So we made these table of values of these exponential functions. Alright? We made the table of values of these two exponential functions. And there's definitely some patterns in there. Okay? Let's talk about some of the things we see. Steve already mentioned, or somebody did, that this one is doubling. Right? Right? What are some other things you notice in either of them? There's always a pattern. And the pattern is always what? Dividing or multiplying. Could this really be considered multiplying?
Yes. Going on.
What are you multiplying by? 1/4. So you're telling me here I multiply by 1/4, here I multiply by 1/4, and so on?
Yeah.
Okay, what about here? Times 2, times 2, times 2, and so on? So in both of them, the pattern was multiplying by a particular number. The b value. Y equals a times b raised to the x power. Look at the b value. It's 1/4. Y equals a times b raised to the x power. Look at the b value. It's 2. That is the number you are multiplying by over and over and over again. What else were you going to add? Nothing right now? Okay. So, the b value is exactly that. Okay? The b value is exactly that. B is the number you multiply by over and over.
So you don't need to find like one value, you can just multiply the rest.
Absolutely, yep. Well, not even that here in a second.
So what is the a value always going to be the 0?
And Jack just said, look at the a value. It shows up in both of these tables of values as well. Okay? The a value shows up in both tables of values. The a value is with the 0. So 0, 20, 0, 3. So really the a value is your y-intercept.
Oh yeah.
Okay? Good. The a value is the y-intercept, or your starting amount. The a value is your y-intercept or your starting amount. And once we kind of get into some story problems, you'll see why I also call it the starting amount, okay? It's going to be the amount of something you have at the beginning, and then over time it's going to change. So the a value you'll always use as your starting amount, okay? But for right now, we'll just say it's the y-intercept. Now, one quick note on that, okay? A is always the y-intercept if this is your function. If they put plus a number back here or minus a number back here, then it won't quite work out that way. Okay? But for the most part, your functions are all going to look like this, and the A value will almost always be your starting amount, okay, or your y-intercept. Any questions on that so far? All right, so there's a little introduction to what exponential functions are. All right? Go ahead and pause it. I didn't get to